Let we start our session with the Unit 3 Combinational Logic. And the first topic is Combinational Circuit Analysis and Design Procedure. So basically the digital logical circuits are mainly classified into two categories: combinational circuits and sequential circuits. So what are the difference between combinational circuit and sequential circuits are? Combinational circuit logical circuits are the one where the output of your combinational depends only on your current inputs. Sequential circuits are the one where your outputs of your sequential circuits depends not only on your inputs but also on your present state. And in order to store that present states, we are going to use some memory elements which are called as flip-flops. So these circuits generates the output based on the present inputs as well as on the previous states. So these are the basic block diagrams of combinational and sequential circuits. So a combinational circuit which are represented with X number of inputs and with a Z number of outputs. So there is a direct relation between your inputs and outputs. So where your Z number of outputs are derived using this X number of inputs. In sequential circuits, the external outputs not only depends on your external inputs but also depends on your current state. And that current state is the output of your memory elements. Where the memory elements would have your inputs from your next state of the combinational circuit. So where these memory elements are known to be the flip-flops. So these next states are being saved in your memory element and they are considered as a current state. So hence your sequential circuit output not only depends on your inputs but also on your present state of the combinational circuits. So combinational logical circuits are memory-less digital logical circuits whose outputs only depends on your combination of your X number of inputs. The outputs of combinational logical circuits are only determined by the logical functions of their current input states, whether it is a logical 0 or it is a logical 1 at any given instant of time. The result is that combinational logical circuit have no feedback and any changes at the signals or your inputs will immediately affect your output. Combinational circuits output depend at all times on your inputs. Thus, a combinational circuit is a memory-less devices. Combinational circuits are designed or made up of your basic logical gates. You can also use the universal gates like NAND, NOR gates along with the NOT gates in order to implement a complement of functions. We're going to use the NOT gates and they all are combined or connected together, which produces a more complicated switching circuits. These logical gates are the basic building blocks of your combinational logic circuits. There are three ways to represent a function and to design your combinational logic circuits are. First way of representing your function is Boolean algebra. Second way of representing your function is truth table form. The third way of representing your function is using your logical diagram. So in Boolean algebra, so we're going to have your algebraic expressions of your outputs, where those outputs are directly gives the relation between your input and output. These input variables are represented either in the form of true or false, which results the output which is a logical one. Truth table. In truth table form, we can represent your function with the possible logical gates by providing a concise list of your all the output states in a tabular form for each possible combination of your input variables that the gate can have. Logical diagram. So using a graphical representation of logical circuit, we can connect your each individual logical gates that represents your the graphical symbols, and we can implement your logical circuit. So these are the three ways of representing your functions. So directly using Boolean function or Boolean expression, we could relate your output and input, the dependency of your output on your present inputs using your Boolean expression, or else using your truth table. So we derive your all the possible combinations of your inputs and their corresponding outputs, or interconnected logical gates that can derive your outputs is another way of representing your function. So you are going to pass the inputs and we obtain your output upon interconnecting the logical gates, basic gates or universal gates. We need to follow some design procedure to design your either a combinational or a sequential circuit. Now, this block diagram of combinational circuit consists n number of input variables and m number of output variables. And these m number of output variables are produced by the internal combinational logical circuit, and those are transferred to the external destinations. For n number of input variables, there are 2 power n number of possible binary input combinations. For each possible input combinations, there is one possible output value. Now, few examples we have given under your combinational logical circuits based on your different applications. So, we can design your arithmetic logical function using combinational logic, as well as we can also design data transmission circuits, code converter circuits under your combinational logical circuit. Example, arithmetic logical functions examples are adders, subtractors, adders or subtractors or comparators or programmable logical device. And data transmission devices are multiplexers, demultiplexers, encoders, decoders. Code converters are the one. So these are also comes under your combinational, and their examples are binary to BCD converter, binary to 7-segment display devices, or binary to grade code converters, grade 2 binary converters, binary to XS3 code converter. These are some of the code converters. Now we need to follow for designing any type of combination circuit some common procedure that is known to be the design procedure of a combinational circuit, where it involves some common steps. First step or the foremost step is determining the required number of inputs and the available outputs on your each combinational circuit. Upon finding that inputs and outputs, we need to assign a symbol to each input and output. After upon assigning the symbols, then we are going to derive the truth tables, which defines the required relation between your input and output. Next, we are going to find the simplified Boolean expression for each output in terms of its input variable using the minimization techniques like K-map method. Upon obtaining that minimized expression, we are going to draw the logical diagram using your universal gates or your basic gates, and then we will verify the correctness of the design, whether it is giving the required output or not. So like this, so this common procedure we are going to follow to design any combinational circuit. So in the next class, we are going to design your arithmetic and logical circuits.